Hello, good morning, good afternoon, or good evening, wherever you are on this beautiful planet of ours. Welcome to Sustainability in Your Ear. This is the podcast conversation about accelerating the transition to a sustainable, carbon neutral society, and I'm your host, Mitch Ratcliffe. Thanks for joining the conversation today. Building and operating homes, skyscrapers, factories, freeways, everything in our infrastructure generates about 10 gigatons of CO2 annually, or 40% of the emissions associated with energy use on the planet. In recent interviews, we've explored reducing the environmental impact of the built environment, usually with a focus on reducing its embodied carbon. That's the emissions generated when the construction materials are manufactured. For example, we've talked about lower carbon concrete many times. But what if the built environment were not a source of CO2, but contributed to pulling that CO2 out of the atmosphere? That's what our guest today is doing with CaptureCrete, a powder additive for concrete mixes that extracts up to 220 pounds of carbon dioxide from the air per ton produced, and that locks it into the concrete as a stable mineral. Tim Sperry is the founder and CEO of Boca Raton, Florida-based Carbon Limit, the maker of CaptureCrete. He founded the company in 2020 after recognizing concrete's huge environmental price. It accounts for 6% of annual global emissions. CaptureCrete's impact, after accounting for the CO2 that it absorbs, is only about 25% of that of traditional concrete. This wasn't Tim's first shot at carbon capture for the built environment. Previously, he developed a paint additive that absorbs CO2 and other pollutants. He's got an interesting story, and his company was named Green Business Startup of the Year at Verge 2023. You can learn more about Carbon Limit and CaptureCrete at carbonlimit.com. Carbon Limit is all one word, no space, no dash, carbonlimit.com. Now let's find out more about this story after a brief commercial interruption. Welcome to the show, Tim. How you doing today?
Fantastic. Actually couldn't be any better. Thanks for having me, Mitch.
Well, thank you for joining me. And how's the weather in Southern Florida? It's been really hot up here.
Yeah, I moved here from the Midwest and originally from California, so I've had kind of all different sides of it. And you get used to the heat and the humidity down here, but it's definitely hot and humid, like kind of you feel like you're in a bowl of soup. But
Well,
it's
those are the times we live in.
yeah, exactly.
Hey, look, you've done carbon absorbing paint and now concrete. What focused your career on carbon removal?
Yeah, actually, starting with the paint, we actually meant it to be a air purifying paint. This was back in 2018, and I was trying to solve one of my own problems, which is I have a really sensitive respiratory system, and I was having issues with indoor air pollutants and probably more sensitive than others, and created this paint that I thought would improve indoor air quality, which it did. Actually removed a lot of your VOCs out of the air, and as we were testing it for certifying it under Greenwise,
Mhm.
we were doing chamber tests and these other tests, realized that in addition to like formaldehyde, ethylene, and like other air contaminants and pollutants that are in the air, it actually was absorbing a good amount of CO2. So as we had the opportunity to exit that company, I got really excited about CO2. And this was about 2020, beginning of 2021,
Mhm.
where let's say it wasn't as big and thing publicly, people were starting to get into it. And I kind of saw like, hey, if we could do something that would reach the gigaton scale of carbon removal, that would be pretty cool. And I see things kind of heading that direction from a commercial side, from a governmental side. So it just came out of as we were doing this product and realizing what it could do, seeing a bigger picture.
Mhm. Well, so how does the CaptureCrete CO2 mineralization process work? Tell us about how it absorbs the CO2.
Sure. So we're using these special natural pozzolans, these active minerals that are selective and reactive to CO2. Some of these minerals are more or less a solid CO2 sorbent, where they're attracting and absorbing CO2 molecules from the air in and around and on its surface. As the CO2 is being absorbed into the concrete, so you're mixing this into the concrete, and it's
Mhm.
actually a partial cement replacement mixed with this metal oxide catalyst. Those two different materials work actually with the cement, and it's pulling CO2 in like a magnetic sponge from the air, and then it's mineralizing that CO2 as it reacts with the cement to form a solid carbonate. So it's actually turning CO2 molecules into a solid mineral inside the concrete.
So how long does it take for a ton of treated CaptureCrete concrete to store that 220 pounds of CO2 that you describe it doing so? Is it immediate during the mix process, or is it something that happens over the life of the material?
It happens generally, we're seeing it primarily depending on the concrete and the design mix and the type of concrete. If you have a
Mhm.
concrete block versus a thick concrete roadway, there's going to be a difference in that time scale. But we're seeing a majority of the front end carbon being captured and mineralized over the first 12 months.
Okay.
So a lot of it is there. And then for carbon credit validation verification and carbon credit verification purposes, we're generally monitoring 12 months from the date of deployment. So this is all happening post cure and during the curing process.
Okay, interesting. Now, how does CaptureCrete compare to traditional concrete in terms of the carbon footprint? Let's walk through what the math looks like because,
Yep.
I understand it's 25%, but how do you get to 25% the carbon footprint of traditional concrete?
Yeah. So CaptureCrete effectively can replace as a cement replacement, which cement is the most carbon intensive part of concrete. It's the glue that holds concrete together, but it's what creates a majority of that carbon footprint from
Mhm.
the processing of the cement, whether it's the fuel energy requirement as well as the CO2 that is emitted when you burning that limestone to turn it into cement clinker. So we're replacing about 30% of that cement in a ton of concrete in the concrete
Mhm.
mix. That gives you some upfront avoidance for the concrete. And then when we do a quantification as the carbon's being captured into it, of course, we're taking the baseline sample, which will be the concrete, same formula as the concrete with CaptureCrete.
Mhm.
And we're comparing to see, okay, how much CO2 is being absorbed and being mineralized during that same time scale of, let's say, 12 months compared to CaptureCrete's concrete. And then what's the delta? What's the net additional amount of CO2? And then we add column A to column B. What's the avoidance mixed with the carbon capture piece? And there's a, depending again on the type of concrete, if you're pouring, if you have stucco or if you have a thick concrete pour like a runway or a road, or you have like a concrete block that's a lot more porous, you get a different level of CO2 that can be captured. But then of course, if you don't, minus your baseline, you're really not getting that net additional. So we're always minusing that baseline.
So it sounds like it actually could be even lower than 25% of the traditional footprint of carbon, but
Yep.
you're only counting that first year.
That's right. Yeah, and it certainly could. And you especially when you have uh, something where we could replace even 35, 40% of the cement, you can certainly call the avoidance piece even bigger, and then the capture rate dependent on that actual type of concrete. And then let's say we deploy concrete where you live, Mitch, where there's less relative humidity and maybe less precipitation than
Mhm.
South Florida in the rainy season. We may get more carbon capture here over those 12 months than you will at your house. So there's going to be a difference in where you deploy this concrete to.
Now, is the CO2 permanently sequestered when it's mineralized inside CaptureCrete?
Absolutely. And that's really one of the best parts is that once that CO2 molecule from the air is mineralized and turned into calcium carbonate, which is
Mhm.
CO2 in its solid form there, uh, in reaction with the cement, it's stored permanently in the concrete. It's actually carbon capture utilization and storage because it's utilized into the concrete there. But even after the service life, say we rip up that road with CaptureCrete concrete, and then we're grinding it down or we're breaking it down, it's thermodynamically and kinetically stable. What does that mean? It means that that solid mineral stays there in perpetuity. You could, put it into as fill. It could go to a landfill. It could be reused as a concrete, recycled concrete aggregate. And the only way it would release is if you're burning it above 500 degrees centigrade, which we're not really incinerating much concrete today. It's better to reuse it, more effective, and it's probably a little bit cheaper. And we're not just burning so much of our landfills anymore, especially with concrete.
It occurs to me that the additional carbon, the carbon calcinate in the material might change the performance and durability of the concrete. How does this change the potential uses of concrete?
Yeah. So let me just start by saying my background is in creation and commercialization of negative emission technology and carbon capture technology. I'm a scientist and an entrepreneur, so I love to create things and then sell them. My background is not into cement and concrete. So I
Okay.
will say this. we created a carbon capturing technology for concrete because we figured, hey, what's creating the biggest carbon footprint and what could be effectively one of our biggest carbon sinks outside of the ocean or outside of forests. To our surprise, to my surprise, not to my team of civil engineers and material scientists, it actually increases the performance of the concrete. So we're actually seeing an increase in compressive strength and an increase in flexural strength.
Okay.
In addition, has some improvements on durability because as it's changing the permeability, the ability for intrusion of chemicals or other things, it's actually mitigating some of those chemical attacks and intrusions, which could break up the concrete or which could cause some degradation of the concrete. So to our surprise, it's improving the performance, which was really a great thing for customer adoption.
It sounds like, for instance, you could use this kind of concrete because of the two different additional capacities that you talked about in arches and other structural forms that wouldn't have been traditionally, at least easily feasible. You would need a lot more rebar in that older concrete than yours, perhaps.
Well, so I would say yes and no there.
Okay.
Yes, because theoretically, we're not seeing, well, theoretically, it's not causing any issues on a corrosion
Mhm.
basis, but we're still testing more durability test for corrosion to make sure we're not causing any rebar because people within the civil engineers and others in the space, carbonation into concrete used to really be viewed as bad. And a lot
Hmm.
of times you get carbonation into concrete because you either have bad concrete and there is intrusions and cracks and things like that, which would get and seep into the rebar and cause spalling and corrosion. The way that we've seen it is we're actually mitigating some of those intrusions and we're not seeing any of that, but we really want to have more long-term tests on durability before we go into like a vertical high rise where it's a rebar reinforced element versus we could go into a high rise that's got concrete blocks or it could be subfloors or it could be other things that will be in there as well. So ultimately we think once we have enough confidence in a lot of these use cases and a lot of these durability tests, we can be into every different type of concrete and project out there.
That's interesting to think about how the built environment will change because of the materials we're using. I mean, if you look at back 200 years, different kinds of buildings entirely because of different materials. Have you talked with your team and with your customers about what kinds of new things we might use concrete for in the future?
Absolutely. I think a big one that's definitely catching a lot of steam that where you have the Moore's law coming into effect with cheaper pricing of materials, 3D printing is a huge one because
Mhm.
it's almost no waste and you could put it into something that actually has the perfect thickness generally. It's a thinner concrete versus very thick concrete, which gives the ability for more carbon capture and more penetration. So I think that's a really big one. We're getting a lot of interest for data centers because let's face it, big
Yeah.
tech companies right now, and when you look at a Google search versus an AI search, you got, a multiple of the carbon footprint that's created. And a lot of us are doing that now. And they're really looking for a way to decarbonize. And that's certainly one of the top things on your hit list when you look at a carbon intensity and also when you're looking at your embodied carbon. So I think that's a really big one too. But then actually to step back to the rebar reinforced, you could use
Mhm.
basalt, you could use fiberglass, you could use all different types of these alternative materials or even coated steel rebar, and you wouldn't have this issue that we were discussing in that last question. And you could utilize that everywhere.
It's really interesting to think about. So much to explore here. I want to take a quick commercial break. We're going to be right back. Now let's get back to our conversation with Carbon Limit CEO Tim Sperry. We're discussing his company's carbon-absorbing concrete additive, CaptureCrete. Tim, how easily can a construction project adopt CaptureCrete compared to the traditional way of making and using cement?
So we were really thoughtful with this piece because as you look at a lot of the solutions that are coming to the market, you have these complex, expensive new pieces of equipment. You're changing the production line, you're changing the process. We wanted to do something that wouldn't disrupt that at all, make it super easily adoptable, affordable, and therefore highly scalable. So a company today making concrete could in fact add CaptureCrete additive today with existing equipment and with the existing process. It would just be like adding a different type of sand or like adding fly ash or slag, some of the other
Mhm.
replacements that are going on in there. So effectively on the actual bigger bigger picture, if you really needed to have an additional silo, maybe the only additional piece that would be necessary. Some of the producers we work with, they have additional silos already, so it's
Mhm.
not changing anything. We could literally gear up a concrete producer to start making carbon capturing concrete with CaptureCrete in a day. It's really pretty simple.
So what is the business model? It's selling to the concrete producer who then sells to the building owner?
It's ideal because our first commercial customer was actually Google. We went through Google's Climate Change Accelerator,
Mhm.
which was a fantastic opportunity. Got to meet a bunch of really amazing folks there, and then ended up getting to do a project together with them. So to that point, when we tried to work with end user customer, they have to backtrack it to the concrete company, and then they have to figure out a way to put it in there. They don't want to do something different because they're used to doing their own cycle and their own system. So it's
Mhm.
harder for us to kind of engage going backwards. So for us, the ideal scenario is we license this technology, CaptureCrete,
Okay.
which is the formula to your producers, and they will integrate the materials, the additive to make CaptureCrete concrete, and then they can sell it into the marketplace. They can, make concrete blocks, they can make ready mix concrete, they can, do a multitude of different things with it. It's just easier to actually get it to the end user that way.
So I understand there are about 6,000 concrete producers in the United States. How are you reaching them and starting to establish these business relationships?
A lot of it is certainly exposure. Others are getting into different projects to prove different use cases. A lot of customer projects that we do, we're doing them primarily to gain adoption and exposure and to showcase, hey, look, it can be done here, or this is your region, regional concrete company A, B, C. Why don't you start adopting this and picking this up? And then we also, generate carbon credits, and that carbon credit piece is really used from our perspective to garner more adoption. So as you talk about 6,000 concrete producers, we look to get in with kind of the smaller ones in different regions, mid-sized ones, and then when we get to the larger ones, which have multiple locations and multiple regions, it's much easier for us to gain market share that way.
Well, so obviously we're still at the proof point phase of this market, but it's really interesting to think about everything you've already accomplished. Tell us about it. We've talked hypothetically about applications of this stuff, but tell us about a couple of projects that you've done with CaptureCrete.
Yeah, sure. So our first project was with the Minnesota Department of Transportation. So we actually did a section of in-service expressway. It's on I-94 westbound in Monticello, which is right outside the Twin Cities in Minnesota. So you can actually drive on CaptureCrete concrete. We did a project in California, in San Francisco, with Google on one of their innovation centers projects, as well as a brick project with one of the bigger concrete producers here in Florida, making CMUs, those concrete blocks that make most of our homes and buildings
Yep.
here. And we're working with different precast companies to make different precast products, which could be architectural, lightweight concrete siding, which could be big pavers for any type of exterior work, as well as for like rooftop tiles. So we're really looking, and our technology is very versatile. So we're looking to get into all those different use cases. And now we're currently working towards a couple of data center site work projects, as well as other, applications, maybe tilt up walls. And that's really the trajectory we're going, is proving out as many of those use cases as possible to engage with the bigger producers to show them, hey, this could go into literally all of your work.
Now, the economics of building are going to change a great deal as we integrate these materials that capture CO2 or at least are much lower CO2. And you generate carbon credits based on the performance of CaptureCrete. Tell us how you validate that and what's involved in this for the building project owner in terms of their economics of their project. Can they use those credits to offset the cost of building the building in the first place?
Sure. Yeah. So the validation portion was very important for us, and it took us quite a while
Hmm.
as we navigated new waters, new territory. Luckily, two registries had a methodology that were already approved that we could fit into. So we used our first one was with Covalent, and it's their carbon mineralization methodology. And our VVB, our verifying validation verification body, was Bureau Veritas, and they actually did a site visit on our block project that I mentioned. And then with Vera, we have a project listed with them, and working with SCS Global, they did a site visit actually on the Minnesota DOT roadway project. And we went there with them, did a site visit, walked down the road because they had it closed down for us, which was really great. That turns into a situation with our customers where we can say, hey, concrete producer A, if you want to work with us, what we'll do is we'll either share carbon credits based on the amount of volume you're deploying and based on the performance of that concrete, or we can do a either share of those carbon credits or a revenue share. Or if there's a third party involved, like a building owner, we can have a three-way split or a two-way split, depending on how that negotiation works out. As long as it's listed proof of ownership and all the required information for the carbon registries there, we can kind of call it any way we want.
What's a ton of CO2 credit selling for these days?
So for us, we have the ability to generate avoidance credits and removal credits, and we're generally splitting those apart. We've tried to offer them kind of blended, but I think people are now looking to see, okay, when you have a blended carbon credit of avoidance and removals, what's that actual percent of removals to the percent of avoidance? So to kind of get away from having to explain that and having to have people feel good or bad about it, splitting those avoidance credits should go from tens of dollars up to the removal credits, which we sell for around $200 and up, just depending on volumes. And I would say that the removal credits are certainly what we're really leaning on as we're moving forward, because one, it's easy to quantify carbon capture from the air mineralized compared to baseline, so we can actually show those removals, versus an avoidance credit, which if regulations come in and say, hey, you must reduce carbon footprint from this concrete, this percent, maybe those credits disappear a little bit, and the ability for them to be valuable starts to minimize.
You just described an awful lot of complexity in terms of assessing the impact and pricing the value of that impact. How do you use AI in your process? I understand that it's involved in your R&D, but also in your measurement, reporting, and verification efforts.
Yeah, a primary piece of that is when we're getting data. So we use third parties to when we're taking the concrete to quantify what that carbon uptake is. We're actually taking these concrete samples from a site or from that specific mix design of that concrete, and we're actually burning those samples between 550 degrees centigrade and 950 degrees centigrade to get mass loss, because that mass loss and that range is effectively the calcium carbonate that's burning off, which is the captured and stored mineralized CO2. So as we have all this data that we're getting from all these different tests that we're doing, we're using some AI and ML on the modeling. So we're modeling what the expectation of service life is compared to the baseline. And also it gives us an easier way to model what the carbonation rate as well as the carbonation quantification will be. So as we continue to get more data, it just makes it easier for us to provide that for MRV to the actual carbon registry, and even give to the customer that data and that information as well.
You mentioned earlier that you could add more CaptureCrete material to the mix in order to increase the absorption rate. Is it possible to build or to make a concrete that literally is carbon reducing overall?
It is, depending on the mix design. And I would say, you have a lot of customers using fly ash and slag, which is an industrial byproduct. Of course, it's an industrial byproduct of something that's not so clean, but you can reduce a lot of cement that way. And if you add CaptureCrete to a version of concrete that has a lot of these other cement replacement materials that would be considered to have little to no GWP based on cradle to gate or cradle to grave from when you're getting the materials, we could get to carbon neutral and potentially even carbon negative, but it's really dependent on that mix design. There's a point where you get a depreciating return of carbon capture. We can actually add more CaptureCrete to reduce and get more avoidance, but there is a point where you have these nanoparticles and these materials that start to actually become counterproductive if you add too much of them. Like the perfect suspension of the perfect dosage rate of CaptureCrete will capture more CO2 than more CaptureCrete in the concrete, if that makes sense.
Too much of a good thing doesn't necessarily pay off, in so many words.
Exactly. Yeah, exactly. That's exactly right.
Okay, so now you've declared a goal of removing 1 billion tons of CO2 from the environment. Now that's not the avoided, that's the removal. And
Yeah,
I did
it's a
the quick
lot.
math. That would require you to pour 9 billion tons of CaptureCrete. When do you expect to hit that goal, and what are the keys to growing carbon limit so you get there?
Yeah, so look, it's a very hairy and audacious goal. And I think someone just needs to come out and do it. The one thing that we love about concrete is that it absolutely has the ability to be a massive carbon sink because it's the second most used material on the planet behind only water. And we're
Mhm.
producing billions of tons of concrete every year, which is producing billions of tons of CO2. So as we look at a very affordable, adoptable, and scalable solution like CaptureCrete, getting it into those major markets is critical. We just actually won or became finalists for the GCCA, which is the Global Cement and Concrete Association's Innovandi competition.
Mhm.
Now, what's great about that is that's the global reach of cement and concrete companies. Now we're interfacing with those stakeholders to figure out how can we start to work with them, and that's actually our next step with this actual this competition, this Innovandi competition. And what's really good news is that a lot of the Chinese, some of the Chinese producers in China has started to get into the GCCA, which wasn't there before. So we're encompassing effectively the global market. I
Okay.
think as more customer driven demand, which has really driven it from our perspective, this sustainable low carbon footprint concrete, more regulations, maybe more carbon taxes, maybe not here in the US, but other places there's carbon taxes, as well as just the need for companies to be more sustainable and want to do good, and also be competitive to the other
Yeah.
ones that are doing it. I think there's a pathway. And look, I'm not saying we're going to do 1 billion tons a year, maybe not right away, but collectively getting to that 1 billion tons, maybe it's 10 years, maybe it's 15 years. Like I love to be optimistic. I'd love to say 2030, but I think it's going to take a little bit of adoption time and scaling time there. So, I'd love to crystal ball it. And I think, within a reasonable amount of time, we can gain significant adoption.
Thanks for being honest instead of blowing smoke. I appreciate that. But now, look, you've done paint, you've done concrete. Are there other applications for this material? Could our roofs be treated with this? What else are you thinking about doing with the carbon absorption capability?
So we're thinking about adding other positive attribute properties to concrete that could do things
Hmm.
like mitigate urban heat island effect while capturing CO2, just making things more sustainable in general. It certainly could ellipse into other carbonated or to other building materials
Mhm.
that have the ability to capture and store CO2. Uh, if you think about asphalt, it's on most of our roadways here, most of our highways. Something that could go into that and this similar type of technology with the similar mechanisms and properties, that's certainly something that we're looking at. Um, you know, I'm I would make a million things at the same time if I could, but I have a wonderful team that keeps me somewhat focused. So I try to stay, getting hyper focused into adopting this, hitting critical mass, and then let's work on something else on the background until we can bring that one out and hit critical mass and continue to go there too. But I certainly think something like asphalt would be a really great thing to do. And look, I think as you look at these novel technologies and these materials from nature that can help heal and protect and improve nature, I think there's certainly other applications that we can get into as well.
So as you think about the construction industry and where we're going, by what percentage do you think we can lower the overall impact of the built environment over the next, say, quarter century?
So I'm optimistic again here. I think certainly concrete is one of the low hanging fruit from an actual impact perspective because not too long ago till now, I think we're seeing from maybe 5% reduction up to 20, 30% reduction. So I think that one's probably the quickest. I think other piece of it is too is if this could also play a role, whether it's building envelope materials that helps reduce some of your electricity requirements inside
Mhm.
buildings can also add to that other side of it because we're looking at 40% holistically between the actual
Mhm.
built environment and the operations of those built environment assets. Concrete is certainly one of the biggest pieces, but then that operation piece after it, I think there's a
Yeah.
lot of play that we have there. Um, but again, that's why we chose concrete is because even a minute and you know maybe see it as a smaller, more insignificant amount can make a huge global impact if you can gain that mass adoption.
The economics of all of this are really interesting to think about in the context of the additional capabilities you described. We have carbon credits today. Could we have heat sink credits in the future? Things like that? Should we think
I would
about the
love it.
environment as the basis for a new financialization of regeneration?
I mean, I think that really balances the scales. You know, if you have these incentives there and then you have these opportunities, and I think all these things can kind of work together. One thing I would really love to see is thinking about like 45Q, which we think about a lot.
Mhm.
It's really built for your textbook direct air capture box fan with a liquid animine solution,
Mhm.
whereas you have these novel solutions which are effectively direct air capture, carbon mineralization, enhanced rock weathering that have those kind of same mechanisms and have the same end result, which aren't included in that. If we could have either that, whether it's more encompassing to these other solutions, or you have a similar type of a tax credit that provides something that would get more ambiguous with these solutions, I think that would be a huge opportunity to gain way more adoption and to really push for that mass market or global market scalability.
A lot to think about and a lot to
Yeah.
follow. How can our listeners keep up with what's going on at Carbon Limit?
Well, we're always looking for whether it's project partners, as well as looking to find new licensees and to keep up with us. You can check us out on our socials, as well as LinkedIn is really the only place that I go. That's my social playtime, and then our website. We're always coming up with new things and new projects and updating it to see and to show people where we're at, where we're going. And then feel free to reach out to us at contact@carbonlimit.com.
Tim, it's really been interesting. Fascinating work. I appreciate all you're doing. Thanks for spending time with us today.
It's a pleasure. Thanks, Mitch. Really great to be here.
That was my conversation with Tim Sperry, founder and CEO of Carbon Limit, which makes CaptureCrete, a carbon absorbent concrete additive. You can learn more about CaptureCrete at the company's website, carbonlimit.com. Carbon Limit is all one word, no space, no dash, carbonlimit.com. After conversations with the CEOs of several low carbon concrete companies recently on the show, including Carbon Limit, Concrete.ai, and Eco Materials Technology, it's clear that the construction industry can reduce its impact if it chooses these new materials. And that choice is an economic one. And as Tim laid out just now, carbon credits and the reputational benefits of choosing low carbon materials are tilting the scales in favor of green alternatives to traditional concrete, which is likely the biggest source of large volumes of CO2 emissions that humans can conveniently avoid in the built environment. The ability to tie carbon credits to building and infrastructure projects is key. Now, think about this. When you sell a carbon removal credit for around $200 a ton, the cost of building can change completely. For example, imagine you're building a skyscraper that's 40 stories tall. You might need 4,000 or so cubic meters of concrete. That represents about 5,700 tons of the material. And if carbon credits cost $200 per ton, that concrete represents a potential subsidy for the project of about $1.1 million. Or if we're talking about a mile of freeway, which requires about 17,200 tons of concrete, the credits generated by using CaptureCrete's absorption of CO2 might be worth $3.4 million per mile of roadway. And the average price of a mile of roadway in Los Angeles in recent years ranges between $20 million and $50 million. So you can see $3.4 million is a material difference in the cost of that road. All of this is real money, real savings that can make projects break even sooner during the life of a building or any kind of infrastructure. Now, if you combine low carbon, carbon absorbent concrete with high efficiency cooling and heating, windows with solar energy film that generate electricity for the building, and other green technology, you can see that a path to a much more sustainable built infrastructure is available to us. The key to making this change happen is awareness, as Tim pointed out. Asking your contractor about their concrete's environmental impact is one way that awareness can spread. Another is to attend local planning commission meetings and asking about their use of materials. Again, we can make a huge difference simply by participating in the discussion. I also hope you'll take a moment to share this podcast or any of the more than 480 interviews that we produced on sustainability in your ear. Folks, if you write a review on your favorite podcast platform, it will help your neighbors find us because you are the amplifier that can spread more ideas so we create less waste. Please tell your friends, family, coworkers, the people you meet on the street that they can find us on Apple Podcasts, Spotify, iHeartRadio, Audible, or whatever purveyor of podcast goodness they prefer. Thanks, folks, for your support. I'm Mitch Ratcliffe. This is Earth911's Sustainability in Your Ear, and we will be back with another innovator interview soon. In the meantime, folks, take care of yourself, take care of one another, and let's all take care of this beautiful planet of ours. Have a green day.